Hi everybody, I'm Karol Herbst and I will talk about what I have been working on Rusticl since last XDC. I've enabled a couple of new drivers. Last year I've basically had it working on everything Clover supported at this, like in the past, but I've enabled it for, Guardian SI, Asahi and Zinc. R600 is in theory also enabled, but it's non-functional. There's some merge requests to fix it all up, but nobody really bothered enough to resolve all the review and everything. So if anybody cares about all the hardware, specifically everything uses the R600 driver, you're welcome to help out to fix it and so that we don't have to use Clover on this hardware anymore. I'm also have in-progress branches for the V3D driver, and the Etnaviv folks are also looking into enabling it, but I don't really know what's the status there. Yes. There were also a couple of new, OpenCL extensions enabled and optional OpenCL features like subgroups are quite important. There's also this image 2D from buffer extension, which is used by some professional video editing tools. So that's also nice to see. And there is also no proper profiling support, which was contributed by the community as well. So that's also really great to see. Yes, and they're like, most of the extensions are pretty small and they're usually just providing some information or allowing some Spiri-related extensions to be used. So there are also other changes. The biggest probably is that we finally have a driver which supports function calls natively, which is quite important for bigger kernels, because otherwise we just run out of memory on the compiler side, and that's not great. Which also means that on LLVM pipe, all the Luxmark benchmarks can finally compile in short time and actually run, so that's great. I'm also now using the pipe context flag compute only. There were some Radeon SI related problems we had to figure out, so that's fixed. This will allow driver to disable certain 3D related functionality inside their context, which they don't have to do anymore. And it might also allow some drivers to queue the compute jobs in a different way, so we can actually have long running compute jobs, because otherwise usually graphics drivers are like saying, okay, if it runs for more than half a second, then we just kill the jobs. And that's not great for any compute related work. So there are a couple of problems I still want to fix or see fixed in all the drivers, and that's basically long-running compute jobs. I think for Iris, it's probably easy to enable. Some drivers might need more information on the screen level to do that. But yeah, that's something I have to figure out. And also the memory mapping CL API is kind of a mess. And the way I'm implemented was mostly optimized towards conformance and not performance. And in the worst case, if you have a discrete GPU and you map some, I don't know, you want to map 4 kilobytes of memory, I still map the entire buffer, which means some drivers just copy an entire buffer to the CPU side and can blow up your memory usage. So that's bad. There's also other work in progress stuff I want to fix, and that's one of the most annoying features is program scope global variables, with basically you have persistent memory between all your compute kernels inside the Spiri. The problem is they can actually have constant initializers on top of the buffer's address, which doesn't sound really constant because the buffer has to be allocated dynamically at one time, and the compiler doesn't know about the address. So in the worst case, this means that a constant initializer of a global variable might have to be spilled to a compute kernel inside its Spiri. I haven't started to do the last part. Everything else is already implemented. Like if I don't have a DOF on such a global variable, it will all work. Sadly, the feature in OpenCL needs everything, and I only have bad and terrible ideas on how to do this billing of constant initializers. Maybe somebody has some great ideas for this. I don't. GL sharing is something which is in work in progress for a long time. It's finally complete, I think. There was some remaining issue, but I think somebody pinpointed it to Iris driver bug. Something ARC specific, so probably doesn't really matter all that much. So that will probably be enabled real quick. I've also looked into non-uniform workgroups. Some drivers are a little bit constrained on what system values they provide inside their kernels, and what's really specific about this feature is that instead of having a fixed block size for all your compute jobs, a block size can change depending on where this block lives inside the compute job. So if it's on the edge, it might be that on some dimensions it has fewer threads, and the only hardware which actually supports all the system values in hardware seems to be the Apple Silicon Asahi driver. So it has a system value for like how is the current block size and how is the size on the NQ side. So I will use this for prototyping it further, and hopefully will be implemented soon. And I've also prototyped shared virtual memory in case there is no kernel support for it, for the Iris driver, but it's kind of, yeah. I gave it some thoughts on how one would actually implement this. The big problem is if the driver has like private allocations which are not visible to the front end, you kind of have to make sure that this the application can't really allocate on the same virtual address space as well. So one idea was to just map this area on the host at virtual memory address space out, but this kind of blows up all the VM usage of every application, and that's kind of bad if you see like, oh yeah, every app is now using 16 GB of virtual memory. So that's not great. So what we could do instead is the driver just says, look, I have a heap here and it starts at this address. And then when I'm in the front end, want to allocate memory, I just use this information and say, okay, I'm not using all the libc memory allocation anymore, but I just do it manually. There are still some details I have to think about. It's mostly like what I was thinking there. I don't know if everything there makes sense. And then there's also like, I think Intel Rusticl implementation is also using their own extension for shared memory. And they have like explicit memory placement so they can decide on where should memory be located. Should it be on the CPU side or on the GPU side? And how does it migrate to the other side? Or is it just visible? Stuff like this. So sadly, in a lot of compute, people want to really see this feature. So I probably have to think more about it and see what works and what does not. So I also have other planned work, mostly the semaphore and external memory extension, which are important in case you want to import Vulkan memory inside your OpenCL runtime. I also want to complete conformance with Verdian SI, where I have 2 bugs remaining, and with Zinc, where I have around 5 bugs I still have to figure out. I also want to make sure that cycle implementation, specifically DPCPP, and Chipstar, which is like a HIP implementation on top of OpenCL and Spurvy. So that's what I want to see. And at the time when I was starting Rusticl, a lot of the buffer-related APIs in Gallium were signed 32-bit values, so I just restricted buffer allocations to 2 GB. But on the compute side, you want to have more. So I decide to clean that up at some point. I also want to have function calls and more drivers, and also more Rusticl-related CI on GPUs. One thing I also want to do in the future is to actually advertise device by default, because currently it's all hidden behind an environmental variable, because applications are really quick and in deciding that an OpenCL runtime is broken, so they just fetch, what runtime do I have, and then just disable OpenCL on that. So in order to not run into those issues, I only want to advertise devices when I'm really sure that the implementation is sound and everything works. And this includes function calls, because otherwise you can run out of memory, and that would be bad. I want the devices to pass the CDS. They also should support long-running compute jobs. I don't know if drivers actually allow us to, run computer jobs forever, but maybe something like, I don't know, 30 seconds or something has to be supported. And in terms of if you have Zing supported and a native driver for OpenCL, I will probably prefer the native driver and try to match like devices on the Zing side and on the native side via the device UUID stuff we have in Gallium. So I also want to thank a few contributors, specifically Antonio, who was doing an ework on the GL sharing extension. Antonio also continued to work after the program was finished to fix remaining bugs and interact with the merge request. Noah was working on random CL extensions and other Gallium-related changes. And everybody else who was filling bugs and submitting merge requests and doing a lot of testing. So that's also great. So yeah, any questions?
So when will Asahi be conformant?
I need scratch memory, and I also need timestamps. But yeah, I think the last one I did on Asahi was like 50 fails and a few crashes. But yeah, that's mostly profiling, which needs timestamps and yeah, crashes due to scratch memory. Okay. If there are no other questions, you can reach out to me. I'm very responsive in regards to any questions. I usually have a lot of questions on Mastodon, so feel free. Yeah. Thanks.